My name is Pavel Lavrenko. I work for RSC. RSC is a Russian-based hardware and software vendor of high-performance solutions focused on extremely dense solutions. And at the same time, we do a lot of work with software orchestration, and then we focused on composable architectures nowadays. Actually, from 2012, I believe, we started our Rackscale design, and currently, with the help of fast fabrics and the merge of NVMe standard, we can do a lot in a composable way. And we have a lot of experience with Lustre already. 3 of our high-performance clusters already in IO 500 list with pretty good marks, without any dedicated storage system on the side. So we do assemble Lustre in a hyperconverged scenarios within our compute racks. And now we do a lot with DAOS. DAOS is great. We love DAOS, but still we see some points we want to address. Is that DAOS requires specially designed hardware platforms, and the overall deployment is a bit tricky. And RSC also maybe considered a HPC cloud provider, and we feel that DAOS still doesn't fit HPC cloud approach very well. And I will elaborate on that. So that our roadmap with DAOS, I would say that 2 pictures on the left are from the DAOS website, and it's shift toward more hyperconverged model. So what we think we can do, we would like to even split it even more. We want to split compute nodes with PMEM and compute nodes with NVMe drives, and we want to distribute all NVMe drives across all compute nodes. So having an entire hyperconverged approach within a rack. And at that slide, I want to show that DAOS really requires a specially designed storage server to have all the possible performance. And at the same time, there's a limitation, which is like a 6% ratio, and it's promised to be like 3% in the future, but still it limits the DAOS capacity. So what we do now, we disconnect NVMe drives from DAOS servers, and we connect it remotely via NVMe-over-Fabric. And a few questions may arise here. The first one, is it good to utilize Fabric for that kind of traffic? And the answer is that is pretty much okay, and it doesn't affect storage too much, because your Fabric is bidirectional, and you can see when client's doing writes, or when client's doing reads, there's an uplink with NVMe traffic and downlink with DAOS object traffic, or vice versa. From the latency standpoint, it doesn't affect storage as well, because we have PMEM and everything goes through PMEM. So for doing that kind of orchestration, we have our software solution, which is called RSC Basis. RSC Basis is a cluster management software where we gather all the knowledge about objects across a cluster with a distributed mesh of micro agents, which is performing auto-discovery, inventory, and we have special language to select objects dynamically based on their statuses, telemetry, configuration, etc. And configuration management is also part of our platform. It's based on other products like Puppet, but the difference is that we have a cluster management database in the core, so we know not only about the particular node, but we can build configuration based on the overall status of the cluster. And we can perform some actions, so it's maybe like a human operator to platform or agent to agent, and we do monitoring on the whole system. And there's a view of topologies we know about. It's not about nodes being interconnected, but also how drives connected to nodes, and we can use that knowledge to create that part of Basis is a storage manager. So I will show you an example for DAOS. It's an actual interface of the system. So what we're doing here, first we filter storage nodes with our language. So like select nodes we want to perform a storage node role. Then we can filter NVMe disks from the cluster. We can connect drives to servers. Then we can run services, DAOS services on top of it. And we choose the right clients we want the DAOS instance to be connected to, and everything plays together. So what you can see on the slide is a configuration schema. It can be saved, and then it can be dynamically applied. For example, our orchestrator can play with a Slurm orchestrator, and they may decide which at some particular application run, which nodes should be selected and which drives should be selected and how they should be partitioned. So it allows us to switch from the model when DAOS server is dedicated to more dynamic configuration when it's just a server with PMEM, and you can use it as a DAOS node, or at some different point of time you can use it for some machine learning or in memory database scenario. We already performed some tests, and you may see that there's some strange fluctuations, but still you can see that the performance is pretty much the same for local NVMe or remote NVMe-over-Fabrics operation mode. So what we achieved now is simple. You can have DAOS with the price of just PMEM modules. You can put some PMEM modules in some servers and then dynamically deploy DAOS. And for NVMe drives, you can collect them from the cluster. But to perform that, you need software orchestration, which we develop. And it helps us to provide DAOS in HPC cloud approach, so it can be dynamically assembled when it's needed. Actually, that's pretty much it. We launched that product, yeah, it works. We are ready.
Thanks a lot, Pavel. Is there any question for Pavel? I think we have time for a few questions.
Hi, this is Tom Nabarro. I work on the control plane for DAOS, and I'm very interested in the work that you've been doing, Pavel. So I was interested in first of all, we've started looking on how to integrate the application of NVMe-over-Fabrics into the control plane management and configuration, and so I'm interested in how you've manually configured that. That would be interesting. And also we're looking at the problem of how to detect configuration issues where you might have the possibility of multiple hosts accessing the same drive over Fabric, and how you prevent that. So in Lustre, they have multi-mode protection. In DFS, they have multi-import protection. And so we're kind of interested in ways of protecting against concurrent pool access. Do you have any thoughts on that, Pavel?
So he's our developer on that in the user group, Anton Brekov. So if Anton can comment.
Yeah,
now.
I'm here.
Thank
Well, we don't use right now any tools that you mentioned, but in our orchestration, we know everything about the NVMe drives, and when it's connected to some initiator, it can be used by other hosts because they're like not any kernel space of the target host, so we don't have any problem with it, and already have some lustre based on NVMe-over-Fabric, and it works well. So I think that we didn't face this issue.
So we just don't do that.
Yep.
And yes, and we have already like a year and a half experience with the Lustre, with NVMe over Fabric approach.
That's great. And with Lustre and NVMe over Fabric, do you use the multi-mount protection?
Well, I think that I don't know how to explain. We can't in our configuration database. We have like some kind of logs on these remote drives, so they can be connected to multiple hosts.
Sure. So you know the topology in advance.
Yeah.
Yeah.
Absolutely.
Thank you.
Yes.
Yeah.
So
okay.
yeah. So actually, how we do that, we know not only Fabric topologies, but all other possible topologies like power delivery, liquid cooling. So we try to build the optimal schema.
Yeah, it's great. I think from our perspective, given it's a file system, there would be benefits in not allowing kind of multiple connections, regardless of, we can't assume that the topology is known beforehand, so it might be something that we need to consider anyway. But thank you. I look forward to working with you further, Anton and Pavel, on integrating the NVMe over Fabric into the configuration of DAOS. Thanks.
Yeah, thanks.